Hey there, in this video we are reviewing the fundamentals of C++ programming. So this is a look back at chapters 1 through 5 of the Gaddis textbook, and this gives us an outline of things that everybody ought to know as we get started with second semester programming. We're going to try to keep this very brisk. If there's something here that you're either rusty on or something that a prior instructor didn't have a chance to cover, you ought to look back at the book as soon as possible, brush up on that, or look for one of my earlier videos from first semester programming that's on YouTube. Okay, so to begin with, what are we doing here? What is programming? That's writing instructions for a computer to perform a specific task, of course, in a specialized programming language, and we refer to this as coding. Now, we can distinguish this from a larger body of thought. What is computer science? That's the study of computing machines in general, algorithmic processes, doing the math to determine what algorithm is more efficient than another one, and the general theory of what kinds of things can be automated. So as an analogy, you can kind of think of this separation like physics researchers versus the mechanical engineers that use that information in order to actually build useful things in the world. And in computing, we have this exact same separation between computer scientists that are probably professors and software engineers that are actually building software at businesses in the world. Both great fields to be in, both great careers. And as we go through this, you can think a little bit more closely about which one matches your future interests better. Okay, a little bit of philosophy. The top number one thing that I think computing is for that will guide us is this principle called don't repeat yourself. Not something I came up with. This comes out of a very famous book called The Pragmatic Programmer by Hunt and Thomas. And so don't repeat yourself, or the DRY principle for short, is a principle that any logical job should be done in only one dedicated piece of code or one single place in a software system. Just one. Why is that? Well, it's going to be faster to write if you don't repeat yourself. It's going to be shorter for other programmers to read. There's going to be less code in which there can be mistakes or bugs to live. If there is a bug, it'll be easier to fix because there'll only be one place to fix it instead of a whole bunch of different places to fix it. So the general idea is, why are computers in the world? Well, computers are made specifically to do repetitive tasks instead of people. In the modern era, people really shouldn't be doing things repetitively. If you are, you're not using computers properly. That's what they're for. So in your work, in programming or other things on a computer, if you ever find yourself typing the same thing many times, one after the other, step back and try to think of a better, shorter way. There really ought to be one. Don't repeat yourself. And we'll keep touching back to this really in all my classes, day after day until the end of the term. All right, so basic I/O, basic input-output. How do we do basic input from the keyboard in C++? Well, of course, that's the SYN object. And when you're using the SYN object, you have to specify one or more variables to receive the input. So that looks like SYN and what I call a right arrow, sending some information into a variable. You can link up multiple pieces of input like this. So you can have another piece of input going to a second variable, another thing going into a third variable. When the user is using your program, the things they're typing are separated, delimited, we say, by white space. And that would include a space or the enter key or even a tab. If the user, here's a little side note here, if the user types more than you've got variables set up for, unused tokens remain in what's called the keyboard buffer in memory for later SYN instructions. So if another SYN statement comes through, the user might not need to type anything. If there's information still in the keyboard buffer, the SYN will just grab that instead. That's really important. Look back, there's some illustrations in the book in section 3.1. Kind of important that you understand how the keyboard buffer works. Now, if you want to include, if you want to input strings that are whole sentences or something that include white space, then you can't just use the SYN object for that. You've got to use the getLine function. And again, that's in the book in section 3.8, and you can see how that's set up. But how do you do basic output to the monitor? Well, of course, you use the count object for that. So with a count object, you've got a left arrow there, and to the count, you're going to be sending some information that you want to see on the monitor. That can be variables, it can be constants, it can be string literals inside quotes like you see here. So for example, if I have count, left arrow, there's a string literal there, the value is, left arrow, the variable val, presumably some kind of number, left arrow, end line, ENDL, which is the constant for a return character, right? What we call end line there. That's what you're going to see on the monitor. A little side note on that, the appearance of those output statements can be modified by several I/O manipulation functions. For example, there's the set precision function to establish how many decimal places you want to see in a floating point number. There's set W or set width to see how big a space you want to see this printing in, and that's back in section 3.7. Now, both sin and count are things that are defined in the IO stream library, so you do have to include the IO stream header for that. If you're using one of those IO manipulation functions, that's in the IO manip library. You'd have to include that header. Okay, basic data types. So in C++, there are 4 fundamental data types. And you might consider pausing the video right now and just quizzing yourself, do you know the 4 basic data types? And if you can say that, restart the video and we'll see if we agree. Okay, here they are. So the 4 basic data types in C++ that are built into the language are integers, right? Foremost, int is the keyword for that. There's floating point data type data, which includes both floats and doubles. There's characters, where the keyword is char. And there's also booleans, things that are just true or false. And we use bool as the keyword for that. Now, details about that. These data types are possibly modified by certain keywords. You can prefix, when you're declaring a piece of data, like an int or a character or something like that, you can prefix them with a prefix either long or short, where you're requesting the compiler give you more or less memory for this particular data type. You can also prefix the numerical types with signed or unsigned. Signed is requesting a type that can store both positives and negatives, right, including the sign. Unsigned means you don't care about negatives and you're going to use the entire space just for positives and zeros. You get, by default, things are signed. So if you just ask for an int, ask for a char, by default they're signed. You don't really have to say that. But if you want them to be unsigned, to not worry about the negatives, you have to write that down. Now, major cautionary note when you're declaring variables with basic data. Remember, in C++, uninitialized local variables, if you don't set them to any number, they start off holding random garbage data. Some kind of information that was sitting in the bits previously, where the memory is getting recycled and you're accidentally getting the information that somebody else put in that storage location. So be really, really certain when you are making new data that you initialize it or get some kind of legitimate input. Don't start calculating or printing variables that weren't initialized, because you're just going to see random garbage that doesn't make any sense. So really try really hard to avoid that. All right, let's dig into a little bit more detail on that. The integer data types. Right? In C++, the integer sizes vary by system hardware. So the registers, which are the storage locations on the actual CPU, C++ can modify the sizes of the integers trying to match that hardware. Now, that's different from a language like Java, where an int is always exactly the same size no matter what kind of computer you're working on. But in C++, we're a little bit more detailed towards how the hardware works. So typical sizes for the systems that we will be working on in our course, you've got the short int, which is just 2 bytes long. You can ask for an unsigned short, which is also 2 bytes, but doesn't have any negatives. And you can see the ranges for each of these types here. Kind of important to be cognizant about that. The basic int type in C++ and R systems will be 4 bytes long. That can store a number from about -2 billion to up to +2 billion. If you ask for an unsigned int, it takes up 4 bytes of the system, and that provides you with a number up to about 4 billion, basically. There's also long and unsigned long data types, and as you can see here on this slide on our system, that's not going to be any different from the basic int. But that's there, so if you are doing C++ programs for a supercomputer, or some larger kind of system, the long will be a larger type there and permit you to store much larger numbers than we can do on our system. So there's some parts of C++ that are really only useful on larger supercomputers. And let's think about just for a second where these numbers come from, because it's not really a mystery. You can just do math on that. If you look at the int type, it's 4 bytes, right? How many bits is that? Well, 8 bits per byte, so that's 32 bits. So since a bit has 2 different possibilities, 0, 1, every time you stack up a new bit, that gives you times 2 as many possibilities in your type. So you can figure out these numbers for the int by doing 2 times 2 times 2 times 2, 32 times, which is to say 2 to the 32nd power. And if you do 2 to the 32nd power, you basically get that number at the end of the unsigned int. You get 4,294,967,296, because 1 gets used for the 0. Feel free to try that out on a calculator. That's where these values come from. Probably talk about that more later, or maybe a different course possibly. But I do feel it's important to be aware there's always some kind of limit in data in a computing system. And hopefully, as you know from first semester, if you do some kind of math and it goes over these limits, you're going to have what's called overflow, and the value is going to appear like an odometer in a car. It's going to appear to wrap around, and your answer is going to be like some kind of crazy negative or possibly back to 0. So avoid doing math that has overflow and goes over these limits. All right, floating point data types. Now, floating point data is kind of interesting. Floating point data basically works like scientific notation. And whereas the integer types can be tuned to different types of computers, the floating point types are standardized by the international consortium called the IEEE, and that stands for the Institute of Electrical and Electronics Engineers. So floating point types, the way they're stored, are generally the same no matter what type of computer or even programming language you're using. So the main thing that I want you to know for this course is that the storage of floating point types works like scientific notation. You've got some of the bits set aside for the coefficient, the multiplier part. You've got some of the bits set aside for the exponent part, what's normally 10 to the power part. Of course, for us, it's really 2 to the power part. So you ought to know that. Know that when you're doing math in floating point, things have to get rounded off all the time to fit the space. That's probably what you need here. That hopefully you'll be covering more details, and I find them to be very interesting in the next course, probably your computer architecture course, which at CUNY Kingsborough is CS 1400. So here's a chart out of the book, gives you a little bit of information. So the smallest floating point type, technically we refer to that as the single precision floating point value. And in C++, we use the keyword float for that. Now that type takes up 4 bytes, and if you do the math on that, that can store a number from approximately 3.4 times 10 to the negative 38th power up to plus or minus 3.4 times 10 to the positive 38th power. So, pretty big numbers. If that's not enough for you, then you can use the double precision floating point type, and that's what we use the double keyword for. No big surprise. Why is it called double? It takes twice as much space. It takes 8 bytes, which is to say, of course, 64 bits. And if you do the math on that, maybe in CS 1400, these numbers can store things from about 1.7 times 10 to the negative 308th power. It's a very, very small number, up to positive negative 1.7 times 10 to the positive 308th power, which is a very huge number, of course. And then there's also the long double precision floating point type. And again, on some systems, there's no difference between that and the double. On a supercomputer, it can be very, very large. I believe on our current system, this table isn't quite up to date. I think on our current system, it is actually 16 bytes actually now. So you actually can store somewhat larger numbers. Probably not going to need that in our course, but it's good to be aware of. Okay, details about the character data type. Of course, characters are very simple. Characters in C++ are encoded as 1-byte integers. And the system that's been around for decades is called ASCII, which stands for the American Standard Code for Information Interchange. The particular list of like what number gets associated with what character. In our book, there's a full table in Appendix A. You can look up if that's important to you. Most days, we'll just let C++ take care of that encoding for us. Or, of course, you can look up the table online. Just look at Wikipedia, and there's an ASCII table right there. I kind of like being aware of that. Now, in addition to character data, you can also use a char to store very small integers. It's technically a number. So you could request a signed char, and which allows you to store positive or negative small numbers, or you could ask for an unsigned char that only gives you positives. Let's think about that just for a second. So again, chars are stored as 1 byte. That's 8 bits. If you do that math of 2 to the 8th power, you get 256, and that tells you how many different values you could store in an unsigned char. Now, one of those numbers is used for the 0, and there's 255 left over for positive values. Of course, if you ask for a signed char, you're going to use about half of those values for the negatives and about half for the positives, and that's how that works for any particular type. So, occasionally if I'm using very small numbers for some purpose, like maybe people's ages, I use a char for that to save space. And sometimes in this course, I'll be thinking about that as an example to keep the example small. So I kind of like being aware of the fact you can use characters for very small numbers. You'll see that a couple times for a small example. Okay, control structures. So if we are thinking about chapter 4 or chapter 5 in the Gaddis textbook, to begin with decision structures back in chapter 4, I believe. There are 3 basic decision structures in C++ or other programming languages. Consider pausing the video here and see if you can answer the question, what are the 3 decision structures in C++? And when you think you have the answer, feel free to restart the video. Okay, here are the 3 decision structures. There's if-else, that's the main one. There's switch, which is customized when you have a particular integer variable. And the one that some people forget about is the conditional operator. Some people call it the ternary operator, that's marked by the question mark colon symbol. And we call it the ternary operator because there's 3 parts. There's the part that's either true or false, and then the second part of what happens if that was true, and the third part of what happens if it was false. So the conditional operator, again, you're basically baking a whole if-else statement in just one line, which is kind of nice. Now, thinking about chapter 5, there are 3 repetition structures, 3 looping structures available in C++ or other languages that are related. So again, maybe pause the video and see if you can answer the question, what are the 3 looping structures available in a basic programming language like C++? And here they are. Here are the 3 basic looping structures. There's while, which I have a little note here, is the pretest loop, right? You check to see whether something is true or false before you go through the body of the loop. Secondly, there's do while, which is kind of similar, but it's a post-test loop. You go through the body loop first, and then you check in a true or false statement to see if you should go back and do it again. And of course, there's also the for loop, which counts as a pretest loop and is specialized for when you know how many times the loop is supposed to iterate in advance, as opposed to the other ones, which are maybe like a user-controlled loop when you don't know in advance. Now, main problem with loops is it's very easy to have an error that causes an infinite loop where you get stuck and that one thing's happening forever and your program never wants to end. So if you're debugging and you find that your program locks up or it stops doing anything or it's printing the same thing over and over again, I would look at the loop and I would think about maybe this is an infinite loop is the problem and think about trying to debug that. Is usually my first guess for that kind of thing. Now, don't forget you can have nested loops. You can put one loop inside of another loop, and we're going to see that a couple times. Important to be aware of. Nested loop is where you have a loop inside the body of another loop. You call the one inside, sometimes you call it the inner loop. The one that you're actually starting off with is called the outer loop. Here's what that looks like in code. So here I have this outer loop that's counting over the variable rows. Rows going to count from 1 to 3. And then inside the curly braces there, what's in the body of that loop? Well, it's another loop. So there's the inner loop, which here is counting over the variable call, which I believe is short for column. So again, that's going to go 1, 2, 3. And I think if you put this together, I think this code is starting to write the beginning of a very small multiplication table in rows and columns of what that is. So the one important thing to realize is that you're going to start off with one iteration of the outer loop. You're going to do that inner loop in its entirety. You're going to count the columns 1, 2, 3. That's going to get done before you go back to the outer loop and start doing row number 2. And then row number 2 is going to do column 1, 2, 3. That'll get entirely completed before you go back for the third row. Sometimes something that I ask my students is, how many total iterations are going to happen here? Like that inside statement to print out, count out the value of row times column for your times table entry. How many times will that printing statement happen here? And the answer is 9. It's going to be the product of the outer loop and the inner loop. So if you put together a fairly large outer and a fairly large inner loop, you're going to be doing a lot of work very rapidly. Notice that as you do this, every time you get inside a new curly brace, you get a new indentation level. We should probably talk about that more. So C++ styling. Hopefully your first semester instructor covered this. Remember that we use a standard styling in our code to make your code easy to read for other people. You know, when you're writing code, there's kind of two things you're trying to service. You're trying to service the hardware and make a program that'll actually run on this CPU, but maybe more importantly, you're communicating with other programmers. C++ is designed to support big teams. Presumably, you've got 20 or 100 programmers all working on the system, and it's really important that everybody's working in a standard style, a standard grammar, and it's really easy to understand other people's programs when you need to add a feature or need to fix something. So this is something that's on our mind all the time. So a couple of main bullet points. Number 1, make sure that you use a comment header at the top of every file that's got the author's name, the date where you wrote this, and a very short description about what the program's supposed to do. Number 2, you should be writing comments at least for each function. They should be proper, complete English sentences, again, just to make it easy for people to read. Make sure that you're aligning statements in a block like you saw in the curly braces there on the prior slide with matching indentations. For my class, I'm asking that every indentation be an actual tab. Some people like to use 1, 2, 3, 4 spaces. Our book generally uses tabs, and I'm asking you to use the same thing. Use actual one tab for one indent to make it simple. I always put, and you're going to see this in every example in the book, in every example of code that I've ever seen, put spaces around any operator symbols, like a plus or a times or an equal or something. You should have a space right before it and a space right after it to separate the things out and make it easier to visualize. Let's see an example of that. So here is a very short little program here, basically to demonstrate the styling that we expect for standard programs or for our class. And you notice that right at the top, you have that comment header, right? It's got the name of the program. It's got a copyright date there. That's actually my name there as the author. It's got a date stamp for when the file was created. And it's got a very short, one-line little summary about what this program is for. Now that style that you see there is the standard Dev C++ style. Dev C++ will actually create that template for you automatically. So I actually do require that for all the submissions from my students in my class. That is required and expected. You've got to do that or points start coming off because I don't know who wrote the program, among other things. Now after that, you notice here in the main function here, every section of code, you've got a blank line and then you have a comment about what the next couple lines are going to be doing. And then you have, in this case, like 2 lines of code following that. So here's where it says, here come the variable declarations. And I'm declaring a double for shares and a double for average price. And the next section down, again, there's another blank line. There's a 1-line comment. And there's a couple lines of code there. Okay, so that's what we expect to see for a longer function. A blank line, 1 comment, several lines of code, like maybe 2 to 5 lines. It's not just 1 line of code. It's not 25 lines of code. It's maybe 2 to 5 lines per section like that. So try to get in that habit. Again, notice I have a space around the operators here with the arrows for the count statement. I've got a space right before, I've got a space right after. Notice with the equal signs on lines 14, 15, same thing. So separate those things out. make them visually easy to distinguish. I would do the same thing for a plus sign or a minus sign or something like that. Notice that on lines 18, 19 here, we had one single very long statement. Lines 18, 19 is really just one statement. It starts at the count. It doesn't end until that semicolon at the end of line 19. So sometimes we do this. Of course, we want to wrap them over multiple lines. If I've written that on one line, it would run right off the end of the screen and I wouldn't be able to see the end of the statement. So sometimes we wrap them there with a return statement there. Notice I've put an extra indent on line 19, and that kind of highlights it's really part of the same statement. So sometimes we do that. Notice that standard C++ style, the braces are aligned in the main function. The open brace on line 12 is directly above the closing brace on line 21, and that's what people normally do in C++. Now, some people use what's called Java style, in which you'd put the open curly brace at the end of line 11. And you know what? I would accept that. So if you're one of the students in my class, I actually accept that, but do be aware that normal C++ style is to have the braces aligned like you see here. And then, as usual, you've got one tab indent. Every line inside those curly braces is indented, and for our book, for our class, it's going to be one tab indent. And if I open up more curly braces, because I have an if statement or a loop or something like that, you're going to get one more tab indent. And again, that's expected, that's required. Every professional programmer does that. So if you're not already in that rather obvious habit for programmers, part of what I want for my second semester course is I want to see students get in the habit of how to write professional code, because that's what companies are going to expect. That's what a review for a job interview is going to expect to see, frankly. So you might as well get in that habit now. And I want to make sure that my students are practicing that all the time. Now, if this is new to you or you're still a little bit shaky on your basic styling, DevC++, the IDE that we use, can definitely help. For that comment header at the top in DevC++, if you go to Edit and then Insert Snippet, Comment Header, you are going to get that exact template at the top, and you can just fill in the name of the program and your name. It'll even fill in the date stamp and a little summary description here. Again, that's all required for my students for every submission in my class. Make sure you're doing that. If you're having trouble with things like where are the braces and how many indents do I need, DevC++ has a subsystem called the Artistic Styler, or A-Style for short. And you can click on A-Style, format current file, and it's going to try to fix up your braces and your indentation and things like that for you. I'm not going to say that it's perfect, but if you're having a lot of trouble, feel free to use that. Pay attention to what it's doing, and you really ought to be in the habit of just doing that on your own whenever you write your code. All right, take a real close look at that. That's what I expect from my students in my classes. Do I grade on this? Absolutely, yes. It's a major part of the grading in all the submissions. So try to be careful about that. Okay, so there's our initial review of things you ought to know from first semester programming. So if you're one of my students, what you ought to do in this first class or first week is go to our learning management system, go under course information, read the course syllabus, check out the course schedule, and make sure you're aware of all the policies for the course. And I also have an initial diagnostic quiz that checks you out for those things from first semester. So go to our Blackboard Learning Management System, go under the Testing tab, go to the Diagnostic Quiz. So what that is that's going to be 20 multiple choice questions from first semester programming. It's timed to 1 hour, so give yourself some time, sit down when you're ready for that. Honestly, most students get done with it in about 20 or 30 minutes, frankly. It does count as the first grade in the course. So once you do that, you will have the first grade. Students that are successful this semester, they're usually getting 18 or 19 or 17 or 16 out of the 20 correct. That's 90%, 80% correct, hopefully. If you get a score that's less than 13 on that, you ought to send me an email and we can communicate about where you can get tutoring or additional assistance to try and be successful in this second semester. Okay, so do as well as you can. It is the first grade. Hopefully you get something like around 16 or 18, and that's a sign you are ready to be successful in second semester. And then when we are in person for our first session, probably I'll go in the book and run some review questions together, make sure we're on the same page out of chapters 4 and 5. The Gaddis textbook has nice review questions at the end of every chapter. I recommend students use that to get ready for the tests. And on our Blackboard module, we have answers to all of the odd number questions. That's under the appendices, Appendix M. And I think that's pretty good to get started for our first day of review, actually. So again, if there's anything rusty there or anything you hadn't heard of before, please, as soon as possible, go in the back, go in the book, or look for my videos from first semester and make sure that you're up to speed before we get started with more advanced stuff. When we come back next time, we will spend a lecture just reviewing chapter 6 on functions, on separating out your program into separate small parts, which is the primary way that you use to structure larger programs. Now, keep in mind, you always have to separate your programs out into separate functions. That's always required from this point on. So, an important subject, and I'll look forward to reviewing that in the next video. I'll see you then.